As I was saying, I'm a senior consultant at Winelect. I'm a Microsoft Azure MVP, partner cloud solution architect, and an MCSE on Azure. And I'm been deep in Azure for several years now. And in the last year or so, I've branched out into some other technologies, including Solidity and Ethereum and blockchains and other technologies such as that. And so I'm going to be focusing on smart contracts in the Ethereum context today, but I do want to kind of give you an idea of what these things are and how they work. Here's our agenda. As I was saying, we're going to be going over blockchains in general. I'm not going to do a lot of work detail on that, but I do want to talk about it, kind of give a background on this, and then we're going to talk about Solidity in particular, and then we're going to go into pull it all together with a 0 to app demo at the end, just to kind of show you how all the pieces work together and what have you. So with no further ado, let's dive right into the content for this. This is our agenda again. And what is a blockchain? A blockchain is loosely defined. A blockchain is a ledger. If you can think about a ledger as a set of records that happen in chronological order, blockchain is a distributed ledger that spreads those across a lot of different nodes, and it's tamper resistant and is secure and verifiable. So these kind of are the core building blocks of a blockchain technology, being tamper resistant, secure, and verifiable, meaning that these blockchain ledgers can't be modified once data has been written to it, and they're secure in that respect, and they're verifiable in that everybody that owns a copy of the data can see exactly what's going on the network at all times. So it's not like one person owns the data, it's rather collectively owned by every node on the blockchain. And the ledger kind of works like this. I wanted to do a little bit to talk about how the ledger actually works. It starts off with a transaction, and the transaction is then timestamped, and it gets a hash from the previous transaction. So what that means is every new record that's added to a blockchain is intrinsically tied to the previous record, going all the way back to the beginning of the blockchain. So every blockchain will start off with a essentially seed block that then acts as the seed for the next transaction that gets written to the blockchain. So and so on. So record 101 in this case came after record 100, and it got the hash from record 100. The data that's stored on a blockchain is invariant, so it can be whatever you want it to be. That's really not what's important to blockchain as much as these three fields here, whatever the transaction ID, the timestamp, and whatever the hash from the previous transaction is. So understanding how they're all chained together gives you the idea of how you create a blockchain. And this ledger is really the fundamental concept of blockchain technology, and really the fundamental way that data is stored on a blockchain. So when you write smart contracts, they are written on a ledger like this. So the data, whatever you write, is written in chronological order with a hash and a timestamp, and you can actually see that visibly on a blockchain. When we say it's a distributed ledger, we talk about this in terms of how the data is stored, and rather centrally stored, like what you would have in the sense of a company like eBay or bank or credit card company, where they own the centralized data. On a blockchain, everybody has a copy of the data right here. And whenever something happens on a blockchain, it's replicated to all the nodes on the blockchain. So this allows any member of the blockchain network to do business with another member of the blockchain network. So it becomes distributed rather than centralized. And so this kind of takes out a lot of the middleman approach to doing business for various kinds of transactions that you might do. So imagine if you were doing something like eBay and you wanted to sell something, eBay acts as a middleman in a transaction process. However, with blockchain technology, the potential exists where you could sell your product on an app that runs on a blockchain, and the blockchain actually brokers the transaction. You don't have to use a middleman like eBay, rather the blockchain brokers that, and you can participate in that blockchain as well. Now, there's a couple types of blockchains I want to bring out, and these are important whenever you start writing various kinds of smart contracts, and they're essentially distributed between public and private with at two poles, and then there's a kind of a middle ground there. Public blockchains are the ones that people are most often going to be familiar with, such as Bitcoin or Ethereum, the public blockchain on Ethereum, or Litecoin. All of these are ones that anybody can participate in. They're open. You can download the software, install it on a computer, and add your node to the network, and then you can start mining on the blockchain. And mining being the process of executing transactions and smart contracts, depending on what context you're talking about. Public blockchains there's many of them out there, and in various contexts they have different things. Private blockchains are used by a closed group, and these have however, there isn't necessarily identity management on the blockchain. Like with a public blockchain, there isn't really any identity management either. You just have accounts out there, and the accounts are essentially a hash, and that account is where your cryptocurrencies are stored. Private blockchains don't necessarily have that, but they are closed in that they don't allow just anybody to use them. So if you have an internal blockchain that you're writing for smart contracts or something that you're using within your organization, that would be a private blockchain. And in response to the inability to do identity management on that, the permissions blockchains have arisen where you can actually ID people on a blockchain that access data. And then there's something called consortium blockchains, and these are partially private blockchains that are managed by a consortium of interested parties rather than any single entity. And these are kind of like a hybrid approach between a public and private blockchain, wherein the entity, the consortiums to come together, create a blockchain, usually to manage some kind of industry vertical. And we see a lot of activity around this right now, particularly in the financial space, with banks and other entities becoming more interested in blockchain technology, and also within the healthcare space, where swapping medical data is becoming increasingly more difficult. So they're thinking of trying to figure out a way to facilitate that in a secure way, and blockchain technology seems to be rising to the occasion in that. So these consortiums are healthcare consortiums or banking consortiums that are creating these blockchains. Now, this is important to realize that whenever you're writing your smart contracts, because it'll have implications on how you design your code and so on when you're dealing with the kind of blockchain you're talking about. Now I want to dive in and talk a little bit about Ethereum in particular. Ethereum is both a technology and a blockchain public network. It is open source blockchain-based computing platform. It is the backbone of the Ethereum public network, and it's also cryptocurrency that can be created, the cryptocurrency Ether. It's the network that runs that, but you can also install Ethereum as a consortium blockchain or as a private blockchain, and we're going to be demoing it as a private blockchain in our work today. It uses Ether, also known as gas, and this is what funds transactions on the Ethereum network. Now, going back to what we were talking about a minute ago with that ledger, now cryptocurrencies in the context of blockchains aren't necessary for blockchains to work. It's one of those things that kind of comes along with blockchains, but fundamentally blockchains are all about the ledger, the distributed ledger, and you don't have to have some kind of cryptocurrency in order for them to work. However, to keep people from abusing a network, sometimes even in the case of private blockchains, having a currency is, even though it has no real monetary value, can keep people from abusing the network. And in the case of Ethereum, that's Ether. And Ether is what essentially funds transactions that get written to the blockchain on the Ethereum network. So it's also the name of the public currency that is traded on the public Ethereum network as well. And the Ethereum virtual machine is what was introduced, and what makes Ethereum made Ethereum so unique was that it introduced this idea of a virtual machine that would interact with a blockchain, and then with that, a virtual machine gives you the ability to run compiled code on that virtual machine that is a part of the blockchain. So if you were looking at it, you have the Ethereum virtual machine, and it has a part of it, that distributed ledger right here, and then it has part of that smart contracts, and these are essentially just apps that are running on that virtual machine. And those apps consume Ether based on some algorithmic approaches to how much RAM it uses, CPU resources, network resources, and other things like that. So with that in mind, let's go ahead and dive in and talk a little bit about Solidity. And we're going to talk about these things on Solidity tooling, the Solidity fundamentals, and debugging. So with that, we have with Solidity, the idea of smart contracts. Now, just a minute ago, we talked about the Ethereum VM. Now, smart contracts are some kind called distributed apps, as we mentioned already, and these are apps that actually run on the Ethereum virtual machine, and the contracts themselves become a part of the blockchain. So whenever you actually deploy a smart contract, it is written to the blockchain and it becomes a permanent part of that blockchain moving forward. And so you can't change the contract once it's been added to the blockchain. Now you can delete the blockchain obviously and then recreate the entire blockchain. And that's what you're probably going to be doing a lot in development is kind of flushing the blockchain and then redeploying your smart contracts to it. But once it goes into a production-oriented environment, you can't go back and change that contract, and so that does have implications on how you write and test software in the smart contract space. However, it is important to realize that the smart contracts themselves do become a part of the blockchain. Now, and the contracts modify states on the blockchain though. Now the contracts themselves can't be modified, the code that, or the bytecode really that's deployed to the contract, but it modifies state. So what the state is essentially the state at the contract as it exists prior to a transaction running. Now a transaction then runs, and then that transaction will change something about the state of that contract. Now I'm talking in generalities, and you'll see this more concrete when we look at some examples, but the state is essentially just the sum total of all the variables of a smart contract that are written to the blockchain. So in the event of an app that's doing mortgages, and it's just tracking the progress of a mortgage, then every time you add something to that mortgage, it goes from one state to the next state, you change a tracker variable on that smart contract, it just writes a new value to the blockchain. The old value still exists in some previous transaction, but the current state is what the most current transaction that ran on that particular smart contract is. So the contract modifies the contract state with each successive change. A new transaction is stored on the blockchain, but it doesn't go back and erase the old transactions, so you can go back and validate that everything was as it was before the new transaction was added to the blockchain. So with that in mind, that's kind of how smart contracts work. Let's talk a little bit about tooling and how this works. Now, tooling within the Ethereum space has matured rapidly in the last few years, and it's actually diversified. So there's actually more than one set of tools you can use. The three tools, really the two tools that I like to use for local development are Ganache, which is a development blockchain, and then Truffle, which is a framework for writing Solidity apps, and also an automation and test framework. And we're going to look at both of these today. And now there's other ones out there that you can use, but these are two of the most common ones because these are probably some of the most mature tools. And Ganache is a really nice tool because it's a GUI-based blockchain, so you can get data quickly without having to run a bunch of CLI commands and see visually what's going on inside your blockchain. And then Truffle is a nice framework. It's a CLI tool, but it's useful for creating smart contracts and also working with smart contracts and the software development process that goes in around building smart contracts with the Solidity language. And then Solidity is the language and tools for writing smart contracts on Ethereum. Now, I do want to mention Truffle is a framework, and Solidity is really the tooling. So it's the compilers and so on for building out the actual smart contracts. And Truffle kind of wraps itself around that and gives you a framework for building Solidity contracts. And so both of these two work hand in hand together to give you a better development experience with these particular tool sets. So that's the tooling. And Ganache is the blockchain, the development blockchain. It's a personal blockchain, so it's a single node private blockchain for doing smart contract development or just playing around with Ethereum. It's a GUI-based tool, and I'm going to demo it here in a minute. It doesn't require is not required to run, but it does give you a nice, easy to use interface. There's what they call the Ganache CLI, and that's also very useful for writing unit tests against and other things like that, for doing automation processes. And but for development processes when you're actually working on this day to day, Ganesh is a really nice tool for it, and it's available for Windows, for Mac OS, and Linux. You can download it at this URL right here. And then Truffle is a framework, like as I mentioned, for Solidity. It does testing and facilitates debugging, and we're going to look at some of that. It's also scriptable because it is a CLI tool, and so you can use whatever your favorite scripting language is, be it Bash or PowerShell or command and batch scripts or whatever it is you like to write in scripting, and then you can command Truffle with that, and that gives you a nice way of writing CI or CI/CD pipelines or just utilities around the Truffle for the use of for building out stuff with the Truffle framework. So that's the tools that we're going to be using in our demo right here on Truffle and Ganesh. So let's get out of the deck and let's launch Ganesh. Oops, let's go Ganesh, and let's just take a look at what this looks like here. I have it on my menu here, and it's pretty straightforward. Wait for it to launch. It does take a second for it to pull up. Once it does launch, it will give me a few tabs across the top of the screen, and that will display what I am talking about with accounts, blocks, and transactions. Now, this hopefully will crystallize some of the concepts we just talked about and going and just the when we were talking about the ledger itself. These are the accounts, and these are what are used to actually call transactions on a particular blockchain. And the blocks on this is where the ledger would appear, and this goes from top to bottom here. And the blocks are the actual blocks that are written to the blockchain. So each one of these has data that gets written to this. And when we run a demo in a moment, we're going to see some of this in action. We'll be able to see the transactions and the blocks on this. And then this is the transaction log. It will show you all the transactions on the particular blockchain. So this is just very easy to use tool, very visual. You don't have to do a lot of work to get this to work. Not a lot of complicated setup. You just click it, it launches it, and then it gives you basically an empty Ethereum blockchain for doing development with. And there's the endpoint that we can use for developing against. Now with Truffle, we can actually do some things with Truffle. So if I go to make dear new app, or it's like a new contract, and I can call Truffle now, and I'm doing truffle.cmd because CMD requires that you add the command prompt requires that you add .cmd to the end of the command in order for it to work. But otherwise, you can just use Truffle, and then you can do Truffle init. And what this will do is it'll create a scaffolding for new contract. That's CD new dash contract, and then I can do new dash. There it is. And now I can do Truffle init, and this will create the scaffolding for my for new application. So you can see here now I have several folders and files that have been created here. Now if I open this up and explore, which should be easy to do, I go Control C, and we can see what's in those folders. And I have a migrations folder, which we'll talk about what that is. A test folder. This is where I put my unit tests, and then a contracts folder. This is where I'd actually put my code that I was writing for within my smart contract. So Truffle gives you just with one command, usually the framework that you need to start developing with these smart contracts. So this is a very easy to use tool. Now you can go open back up my command prompt here, and I go Truffle, and I do -- help. It'll truffle.cmd -- help. It'll list you the commands that you can use. And I ran a init. It's got compile, migrate, and deploy are the synonymous to one another, and that's what we'll use that to deploy contract later on. You can use create to create instances, we're going to be looking at debug to interactively debug. Now this is still rudimentary right here, but it does give you the ability to step through code. And then you can also use console to interact with the contract and call RPCs on it. And then you can also use other commands like publish things to the Aetherium package manager. It's got a built-in package manager with it. There's a lot of other things you can do with this. Now, init deploy, debug, and console are probably the most commonly used commands for this. But these other ones do have their uses as well, and tests as well. That's a commonly used one whenever you're writing unit tests in Solidity for this. So Truffle is going to be your bread and butter whenever you're dealing with smart contracts. It is your Swiss Army knife for doing Solidity development. Now, it's not going to write the code for you, but it does give you a lot of head starts in terms of building the frameworks and a lot of the other types of automations that would go into building Solidity applications. So with that in mind, let's go back to our deck and let's talk a little bit more about Solidity. And Solidity is the primary language for writing these contracts, and it's based heavily on C++ and JavaScript. It's going to be, the syntax is going to be very familiar if you're used to C++. It has a lot of the concepts of this came out of C++, particularly the way it does inheritance. For time's sake, we're not going to be able to get to in detail in this webinar, but it does give you the ability to do a lot of the concepts that you would find available in C++, but they wanted to be syntactically similar to JavaScript. So some of the syntax in the actual smart contracts will be very familiar if you're used to doing JavaScript development, but it borrows some paradigms from Python, particularly as it relates to inheritance, which again we're not going to be able to get to for the sake of time in this webinar, and it also borrows some things from PowerShell as well. So with those four languages, probably the one that's mostly influential would be C++, and with the second being JavaScript, and the other two distant ones would be Python and PowerShell. So if you have any background in C++ and JavaScript, definitely bring that to the table. It will help you become a Solidity developer more quickly. But if you don't, it's going to feel like you're going back in time in a lot of ways, because Solidity is it is an evolving language. It's under constant development right now, and because the Ethereum space is emerging so quickly as of right now, it does make it challenging sometimes, because the documentation is rapidly changing as well. But they do document what they do deprecate. They do document well new features and so on that are being added to the language. Solidity contracts compile into bytecode, and they get compiled to the Aetherium VM, which we mentioned already, and just some paradigms. Uses static typing rather than dynamic typing. It supports inheritance from other contracts, which work a lot like classes do. It supports structs, and can have arbitrary data hierarchies with things like structs and contract hierarchies in this case, and so on and so forth. So it's got a lot of the similarities that you would have paradigmatically with what you would have in C++. Again, we talked about state already and what that means. Now with Solidity contract, with Solidity, where it varies a lot from other languages, is it's all about modifying the contract state, and as the contract executes transactions, new transactions modify the state. And so all the data, every time you call a procedure, anytime you change a value of a variable that's written as part of the contract state, it gets written to the blockchain. So it's implicitly writing data for you. You don't actually have to explicitly write something to the blockchain. It's doing that for you as a language. But the state is constantly being modified with each transaction, which is called by way of RPC. And the contract maintains the state between transaction calls. And this is what I was saying. The state follows the life of the contract. So from inception to end, whenever you deploy the contract to the blockchain, that's when the first transaction for that blockchain is called, and that's when the life of that contract begins. And until you do what they call self-destruct the contract, it doesn't actually delete the data, it just makes the contract unusable. And so whenever you go from beginning, the beginning of the contract is when you deploy it. That's like calling the class for the first time, and it actually has a constructor which Solidity supports, to the time you call self-destruct on the contract. For that entire time, the state of that contract is maintained, and the state of that contract is being written to the blockchain with each subsequent transaction that's being called. Now, there are kinds of transactions that don't modify state, and those don't write data to the blockchain because they don't modify state. However, those that do modify state, transaction calls that do modify state, do write things to the blockchain. And so that's important to remember. Important to remember whenever you're doing smart contract development, is to differentiate between your functions that do write and to the blockchain, and those that don't. And we'll look at an example here in a minute at what that is. And we already talked about Ether. So here's an example of a hello world type a smart contract. I do want to look at this code here, and this is you can compile this code. We can take this code and we can actually compile it. Now the version up here, this pragma, this is a C-ism, if you will. Basically is something that tells the compiler to do something. And in the case of Solidity, the Solidity compiler tells it what version of Solidity to use. And so you can use 4.x, so I think it's up to 4.23 right now, and it's constantly evolving. So the Solidity compiler is versioned such that if you have something in your code from an older version of Solidity, it does know better than to throw exceptions based on compilation errors based on the version of Solidity that you supply in the pragma up here. So that's important to have that whenever you're building your contracts. The next thing is your contract name. Now, this one I've called Hello World because this is what is used in whenever you're calling the contract. This is also what you use in inheriting the contract, and among many other things. So the name of the contract becomes very important, and as it would in a class in the case of C++ or other class-driven languages. And this is a state variable. The reason this is a state variable is because this is stored outside of a function. Now, in the case of this function here, because this is a parameter variable, it's not a state variable. It doesn't get written to the blockchain. This new value won't if it just remains a state variable. However, in this code, I'm actually assigning the value here to the state variable. So at that point, it actually gets written to the blockchain. However, the parameter never gets written to the blockchain unless I tell it to write it to a state variable. And here, the state variable, because it's declared outside of a function, is what becomes a state variable. And so it's not initialized with any value. In fact, it takes the value of 0 to begin with. And that's its initial value. And so whatever I pass into this set storage is what actually gets stored on that state variable. And then of course you have a function. Now this one, notice that this function modifies a state variable right here. And this is one of those functions I was talking about a minute ago that actually writes something to the blockchain. And this one would actually take Ether to run this particular function. This function down here does not change anything about the blockchain. So it's declared as a public constant, which basically means that it doesn't write to the blockchain. And if I did try to write something to the blockchain, in other words, modify a state variable in this contract, it would throw an exception and wouldn't allow me to do that. However, you can have read-only functions in your contracts. Now, this is useful for getting data out of the contract without actually having to use Ether. And so for checking the state of a contract without actually having to call a function that would actually modify the state. So they do support pretty much unlimited reads on a contract without actually costing anything. However, writing and changing something about that contract does require that you pass Ether with it, and then that it actually costs Ether to change the blockchain. And so if you have this contract, you could actually take this code and compile it, and it would work as an example. as I mentioned, there are two types of storage. There's what we call storage, which is written to the blockchain, and memory storage. And memory storage is what if I wanted to actually use something in memory, I declare it as such. And these are variables that are just not written to the blockchain, memory variables or parameters in that case. Storage variables are used for storing contract state, as we've mentioned already. This whole struct here is a storage variable. So it is anytime I'm well, it's declaring a struct. So anything that uses the struct would be a storage variable. So in the case of ballots, an array of structs right here. This ballot variable uses an array of this struct right here. So this becomes my storage variable that maintains the state for this particular contract. And they're used they're declared outside of functions. They're persisted on the blockchain, and memory exists within the function and are not persisted data. So that's important to differentiate the types of storage on the blockchain. Now, I do want to talk about truffle debugging too. Now, this is going to be something that you do a lot of whenever you start doing truffle development. Now, I'm not going to go into detail a lot about the inner workings of a smart contract. I'll let you go out there and read the documentation. I'm glossing over a lot of what the Solidity language is and how it works, but you can go out there and read the documentation and get into details on there. I did want to talk about those kind of highlights of the language. I do want to talk about debugging because you can do a lot of debugging with this. This is kind of a new feature with Solidity, so it's a nice feature. It's still a work in progress. So eventually they want to integrate. Truffle wants to integrate this into Ganesh. For debugging in the GUI. It doesn't exist yet, but you can still do it in the CLI with Truffle Debug. So let's go do a demo on debugging, and I'm going to do this. I want to deploy a smart contract, and then I want to execute that smart contract and go into the code. So let's go back to Explorer here, and I'm going to open up my drive. And let me go to some demos here. I have a good demo right here for this. And let's use my struct demo here. So I'm going to take this demo here and go D:. And this struct demo has that scaffolding that I created with Truffle and Knit. So I've already actually opened this. So let's look at the contract here, what this looks like. And this is my smart contract here. And it's just doing various things with struct, and this is actually doing a seller. It's trying to mimic an online auction. And so what this allows you to do is it maintains a struct of items that are being sold on this particular auction. So let's go over here to my command prompt, and let's deploy this contract to my Aetherium blockchain that I already have up and running with Ganesh. So to do that, I'm going to run truffle.cmd, and I'm going to call deploy --reset, and I'm going to specify the network. And what the network is a predefined and a config file, that truffle.js file there that, of course it didn't deploy, I'm missing a dash, that tells me what the parameters for that network are, and that's basically telling me where the endpoint for that is. And now with this particular contract, I have a address for it. Now the address for the contract is important whenever I want to interact with that contract. So if I go Truffle console, and I'm going to do --network again, and I need the address of the contract in order to interact with it. So I'm going to connect to my Ganesh. I forgot to add the CMD again. I've been working with PowerShell and on Linux for a while using Ganesh as well, and Truffle, and you don't have to add the CMD. And now I can do I can interact with my contract. So if I go struct.at and I pass in my address for that contract, I can actually interact with it and call a variable. See, this gave me the API for that essentially. This is what they call the ABI, and that's the output for this contract. So with that command, I can tell I'm going to interact with that structs contract at that address, and I can call one of the functions on this. And in the case of this, I need to add an item. So now let's go function add item, and I'm going to call add item, and I'm going to say my hat or something like that, and that will add a hat, if you will, to the contract. Now, to get the transaction hash right here is what I need to get to debug this contract. So let's go look at our blockchain just for a second here. I deployed that contract, and you can see here I had several transactions that have been added to the blockchain right here. I have a contract creation, I have a contract call, and this is the latest contract contract call right here. This is the one that actually added my item to this auction smart contract here. And if I go back to my blockchain, see I have some new blocks, and this is the actual block that I used to add that item to my blockchain. And if you go in here, I can look at the transaction data for this and so on. And there, if I went into a hex editor, I could see that it was adding, I could actually see that data in this transaction. But to debug this transaction, I need this transaction hash right here. So I'm gonna grab it out of Ganache and go back to my Truffle console. And if I go debug, and I go, oops, let's go debug and paste that in, it's gonna allow me to interact with it's going to let me interactively debug the contract and see exactly what lines were called in that stack, and that's within the stack. So if I hit in, it's going to tell me what line. It's going to say add the 15th line of the contract. It called the add item in, and then it's going to go item push, add that item to my items array, and it's going to evaluate all the variables inside of that. And you can see how it's stepping through the code with each one of these interactions, and then it's done. So that's how you can interactively debug things with this. You can see where the flow is in the app. Now, some of the functionality it's not complete yet, so this is kind of in the early stages of debugging, but it is evolving very quickly with Truffle, and it does give you the ability to do interactive debugging. That's not something that has existed in the past with Solidity contracts. Let's go back to our deck here, and I want to talk a little bit about pulling it all together, and how you would actually go about doing some work with Solidity contracts. Now, to interface with these, you have Solidity provides a means for writing the code of the contracts, and these are called by RPCs. Now, what the idea behind the remote procedures calls is use what they call a Web3 client. Now, Web3 client basically is referring to the kind of client that this is. No, we've already seen quote unquote Web 2.0. Web 3.0 is what the creators of the Web 3 clients are calling. I believe that the next iteration in web development is going to be a decentralized web. And so Web 3 refers to this next generation web technology, which is all distributed rather than centralized web servers. You're going to have distributed web apps, and they believe that that's going to be kind of the next iteration of what's going to happen with the next generation of web apps, and that the idea of smart contracts is going to be the way that we develop these apps in the future. And there's a lot of debate as to really whether or not that's true. I don't know. I don't really have an opinion on it, but that's the reason why it's called Web 3. And with that, what it builds is the ABI, and this application binary interface is which, when you compile your code with Aetherium, it creates an ABI, application binary interface, and this is essentially just a JSON file or something that points to the endpoints, if you will, within the context of your smart contract, and then your Web3 client will take that ABI and expose it as an API in whatever language you're using with whatever language you're using to interact with it, be it JavaScript.net, Python, Java, whatever. All of those language have a Web3 client that use the ABI to create the interface for interacting with a smart contract that's just deployed on Ethereum. Now, Truffle outputs an ABI in the build folder, or you can call this this command here. The Solidity compiler has a tool called Solidity.js, and you can specify, give me the output for a particular contract, and it'll generate an ABI file for you. And so with that in mind, those three things are what you need to interact with a given contract. So you need the endpoint, which is the endpoint for your blockchain network. You need the address of the contract, and then you need the ABI. So when we ran our last demo right there with the debug, we deployed that contract, and I used the address of the contract to actually call something on that contract, and it was at the endpoint right here, which was my Ganesh network, and then the ABI was implicit to that address. But whenever I'm going to write code, I need to actually specify that in my code. So that's what I want to do with my Web3 client. And I'm going to use Web3.js, which is available for Node and in-browser development. You can install that with npm install with Web3. So I'm going to do a little demo here using Node.js as a 0 to app demo using Node.js. And I'm going to use a Web3 client. That's going to kind of pull all of this together. So let's do a kind of a 0 to app demo, if you will, and talk about the way this would work with an Aetherium. So let's go back to my command line here. And let's go back to my app here, this new folder that I created. I think I created it under C:. There it is, that's the folder I'm looking for. I want this folder here, and I want to use this as the basis. Since I've already run npm init, I created the scaffolding for this. So what I need to do now is actually create a contract inside of this. So within the context of this demo, I wanted to use a contract that I'd already written here. Not in my downloads folder, let's go to my desktop here, and I have within my desktop, I have too many folders in my desktop is what I have, this vote app. And in this, I have a Truffle folder, and this is my scaffolding here. And I have my contract called vote. Now, the vote contract here looks like this. It's very simple. It's just counting votes for two candidates, in this case, Clinton and Trump. So I'm going to vote on these two candidates. And this is my smart contract. So I'm going to take this smart contract and actually deploy it. So let's copy this code essentially into that app folder that I created just a second ago right here. So let's go right here and let's go here. And I'm going to actually go back, grab that contract, go forward, and I'm going to drop that into my contracts folder. Now, in order to deploy this, what I have to do is I have to create a migration script in my migrations folder. So again, I'm going to go back to my old, that's my new contract. I'm going to go back to this vote contract here, and I'm going to get my migration script here, and I'm going to grab, let me close Outlook so I don't keep getting these alerts, and I'm going to grab these right here, and then I'm going to go back to my desktop, go back to this folder here, sorry, and grab that contract, grab that script, back, grab that script there, go back here and deploy that into my migration. Now, what a migration script does is it just deploys the contract to the blockchain. So what I did is I created a new contract with that vote.sol, that's the Solidity contract, and I created a deployer. Now that I have the deployment script, so now I have the deployment script or migration script. Now that I have those both in the contract, I need to wire up my contract, my Truffle environment here, to talk to my Ganesh network. So again, to do that, what I'm going to do is I'm going to borrow from that other that other folder, I'm going to go back over here and look at truffle.js here. Now, that's my one for my new contract that I just created. I want to import my Ganesh settings into this contract here. So I'm going to borrow this code right here and paste that into this. And what this Truffle.js is defining is a Ganesh network, and this is my Ganesh network that I have defined that I've already created already. So with that in mind, I can save this, and now I can use that Ganesh network with my Truffle environment here. So now that I have all those things in place, I can actually deploy my contract. So if I go truffle.cmd, I remember to add it. Remember to add it this time, and I can do deploy, call reset, not dash deploy dash reset, and then I'm going to call network, and I'm going to say Ganesh, and that's going to deploy my contract. If I could spell truffle, that would help too. One more time. There we go. And that will deploy my contract. That'll both compile and deploy my contract in one step. So it's compiling those, and now it's running. Now, the vote address is right here. So within that context of that given app, I now have this Truffle framework. I've created the framework. I deployed a contract to it. I deployed a migration script, and now I've ran the compilation of the contract, and then I ran a deployment to that network. Now it's ready to use by an instance of my application. So I'm gonna go back to my app right here, and let's go revisit that vote app right here. So instead of rebuilding this whole app from scratch, I'm just gonna use this folder here to demo this. So let's go cd to this, and let's go to my DC colon, and there's my app. In my app folder, and it's a Node.js app. Now I would call npm install if I wanted to install some dependencies here, but I'm not going to do that. I'm actually going to edit my index.js with that address. Notice here I have the Aetherium endpoint and already defined, and I have the address that I need for that contract. So I need to call Truffle again to get that, or copy that address again for my vote contract, and deploy it and paste it into my code here for Node.js. So I have that the endpoint for my Aetherium network. I have the contract defined there, and down here is my ABI that I already had defined. Now I copied and pasted this code out of the output for that contract, and that's the ABI. So with those three things, I should be able to run this app against the contract. So let's go ahead and launch my command prompt here again, and let's launch Node. In this case, let's run node index.js and see if this thing won't talk to my smart contract now that's running that vote smart contract. So let's launch a new Chrome window here, and let's go to localhost 8080 and see if this pulls up. Okay, so far so good. This is my vote app. Now to run this, I need to actually get an account address, and let's go back to my accounts here. I'm going to get an account address. In order to vote, I need an account address, and basically this limits me to one vote for address. So if I wanted to vote for Clinton, I cast my vote for that address, and it tallied one vote for her. And it added a new transaction for that vote. So notice I have 10 transactions right now, or blocks, because we're doing one-to-one block mapping between transactions. Now, if I come back over here and get a new account, let's come back over here, get a second account, and let's vote for Trump. I cast a vote for Trump right here, and I should have 11 blocks on there and 11 transactions, and each one of those new transactions is being written to the blockchain as I add new data to that blockchain with new votes. And if I try to cast a vote again, it won't let me because I've already cast a vote for that particular contract, even if I try to vote for another candidate, and so on. So this is the actual an actual Node app using a web front end with a Node app running in the background to interact with that smart contract in the background. So that's kind of a 0 to app instance of my demo. Now, for a 0 to app instance of a demo. So the next steps would be to what to do next. We can help you with training. We have some in-depth training that we're developing on Like now. If you want to, and if you're interested in more for blockchain and Solidity, we have some current content out there that's particularly oriented to Solidity. We have some that'll be coming out very soon. That'll be dealing with Solidity, and we'll be working on some more blockchain content related to Azure development and blockchain content there. We can also do instructor-led training on either remote or on-site if you are interested in doing Solidity development or for many other content, many other types of technologies as well. And we can also do consulting work on blockchain projects. And if you're just interested in following me on Twitter, that very much appreciated. I constantly post about new things that are happening on blockchain technology, and kind of post the latest news on my Twitter account, so it keeps you up to date with that. I do have time for questions. It is a few minutes for that, so please post any questions if you have them. Okay, the first question is, what offerings are available for developing and coming for C# from a C# background? As far as developing smart contracts and Solidity are concerned, there are not many options out there for developing smart contracts. However, you don't have to write smart contract. You don't have to interact. Like I was using Node.js to interact with my smart contract. You can use a project called Aetherium. It's like .NET combined with Aetherium to create Aetherium to interact with smart contracts and what have you. However, I will say if you have a C# background, learning Solidity will be fairly straightforward, because learning Solidity is not, because it is heavily influenced by C++, and so is C#. You'll feel right at home with it. It's not, I mean, there are some interesting developments in the or idiosyncrasies with Solidity. However, you don't have to have a background in C++. You can take your background in C# and apply that to Solidity, and you'll feel right at home, I think, with Solidity language. Okay, what's the difference between slide chain and plasma? Do these have any relation to sharding? As far as I understand it, there are some approaches to solve escalation within Aetherium. Sidechain and plasma. I am not familiar with. Okay, I'm not 100%. I understand the context of the question. I do. I guess it has to do with with how the delegation of executing a smart contract is handled. Maybe I'm not. Again, to add variables to existing smart does it? Okay, let me go back to the previous question real quick. With sharding, I'm not familiar. I'm not real deep on the actual what goes on in the inner workings of the Ethereum network, because my focus is primarily on Solidity. So I'm not 100% sure I can answer that question with escalation within the escalation issue within Ethereum. I know that there's some different issues as it relates to how it works in whether it's proof of work or proof of stake, in handling the who gets to execute the contract and so on. I know that proof of stake is on the horizon for Ethereum, and is supposed to handle a lot of the performance issues and other things related to escalation and what have you. But the sidechain and plasma issue, I'm not 100% sure I can actually answer that question, but you might need to ask that in the Ethereum forum, because I don't think I'm the person to answer that. Next question is, to add some variables to an existing smart contract, does the app have to be updated or redeployed? So what happens to the previous transaction history? If you want to add new variables, you have to redeploy the contract. Now, and any history that's tied to a previous contract is destroyed. if not destroyed, it's essentially if you destroy the contract or destruct the contract, it doesn't erase the data. It's still on the blockchain, but it renders that contract unusable. So to add a variable, you have to redeploy the contract within the context of the blockchain. Now, what that means is that your contract should have, you probably don't want to use contracts ad infinitum. So without ever assuming that they'll never change. Rather, keep your contract data, the data set that's contained within a contract, small. So you can't update an existing contract by redeploying it. You have to recreate it. Now, there are some patterns, however, that you can use within contracts that will allow you to migrate data. There's some patterns that you can use that will allow you to have single endpoints, but allow you to have variability, like with proxy contracts, single endpoints for your applications, so that you can version your contracts. So in the event that you do have a new contract version out there, you can go out and have a proxy contract, and then one of the variables in that proxy contract is the address to the new version of your existing contract, and you just point the proxy contract to the new version and sunset the old version and then migrate the data. So there's some things like that. So the transaction history and so on, if you want to migrate data between contracts, these are expensive processes that do take a while. So again, it's one of those things that you want to really consider what you're storing in contracts and what have you. But that is a very good question. It is one of those the stories, one of those things that's constantly being researched and with smart contracts on Ethereum and what have you. If there's no more questions, we'll call this a wrap. I thank you for your attendance this afternoon, this morning, whichever it may be for you, and look forward to seeing you on future Winelec webinars. And we'll be deploying this as a recording, so you can go back and review the demos, and we'll be posting some of the source code as well, so you can look at that source code. So thanks. Hope you guys have a great afternoon, and it's been a pleasure.